Good morning, everyone. So welcome to my YouTube channel, Master. So today we are going to see second lecture on group automorphism. So let us start today's session now. In last lecture, we have given the definition of automorphism, okay, homomorphism, all these things. So in last lecture, I made a silly mistake, a small mistake. I will like to correct here, okay. So recall with definition. Note that for automorphism, we always take G1 star 1 is equal to G2 star 2. Okay. Both the groups we will take equal. For automorphism, the same group will be both the sides, domain and codomain. Okay. So I am calling it G star. Okay. Now we write the definition of automorphism. Automorphism of a group G. Okay. So what is the definition? Automorphism of group. Let G star be a group. Okay. Then a homomorphism F from G to a homomorphism G, a homomorphism F from G to G is said to be an automorphism of G if. So you should check here whether this is homomorphism. If function first of all should be a homomorphism. Okay. So homomorphism you have to check. So in the definition it is given that it is a homomorphism. Whenever some question is asked to you whether this is automorphism, first you will have to check whether this is homomorphism or not. Okay. I am writing here that it is a homomorphism as well as it should also be 1, 1 and on 2. Okay. So F is 1, 1. Second, F is on 2. Okay. Okay. Now I am writing an example. Okay. That is in your book. Example. So that A maps to A inverse A maps to A inverse is an A maps to A inverse A maps to A inverse is an automorphism of a group G if and only if and only if and only if G is abelian. So we have to show that the map A goes to A inverse is automorphism of a group if and only if G is abelian or not. Okay. So let's see its solution. So this map is given A goes to A inverse. So I'm writing in terms of F. Let A goes to A inverse for all A belongs to G. Okay. Now F is 1, 1. This map is 1, 1. F is 1, 1. So this map is 1, 1. Why? Let A and B belongs to G such that FA is equal to FB. Okay. Now FA is equal to FB, it is given. So what is FA? A inverse. What is FB? B inverse. Okay. So take inverse both the sides. So I can take inverse both the sides. Okay. Taking inverse both the sides. We are taking inverse both the sides. So A inverse, inverse. B inverse, inverse. So in a group, inverse of the, if you take 2 times inverse of the element, you will get that element. So I am taking inverse of A and again I am taking the inverse of it. So it is nothing but A. And what is this? Similarly here. So I started with FA is equal to FB and I got A is equal to B. This implies F is 1, 1. F is 1, 1. Okay. Now F is on to. F is on to. Let A belongs to G. Then by existence of inverse, A inverse will belongs to G because every element in a group G has inverse. Okay. Now, what is the F A inverse? That is nothing but, if you take element here, there will be inverse. Okay. What is this? But this is nothing but A. Okay. So what we got? Given any element A belongs to G, we get another element A inverse belongs to G such that F A inverse is nothing but A. So this implies, therefore, F is onto. F is onto. Okay. So this math is already on one on onto. Okay. Now we will assume that now it is given that this is automorphism of a group if and only if G is abelian. So we will assume first that G is abelian. Okay. So first assume that G is abelian. Okay. So we have assumed that G is abelian. We have to show that F is automorphism. It means A goes to A inverse map is automorphism. We know that already that F is 1, 1, and 2. We need to show that it is homomorphism only. Okay. G is abelian. G is abelian. So this implies AB is equal to BA for all AB belongs to G. Because a group is abelian if commutative property holds. So G is abelian, implies AB is equal to BA. Okay. Now F AB is equal to, what is this? AB is the element. I am taking inverse here. So what is the inverse of AB? Always B inverse A inverse. But G is abelian. Since G is abelian, so A inverse, so B inverse, A inverse, B inverse is equal to B inverse A inverse. Okay. Because G is abelian. So what can I write here? A inverse, B inverse. So what is this? This is A inverse is FA and B inverse is FB. Okay. So what we got? This implies FAB is equal to FA, FB. Okay. Now F is homomorphism. So this implies, what did it imply? What is the meaning of this? F is homomorphism. This implies F is homomorphism. Okay. Since F is homomorphism, one and on to we get F is automorphism of G. Okay. Now we have shown one dimension. If G is abelian, F is automorphism. Now conversely assume that we have to show converge part. Conversely assume that F is automorphism of of B. Then, if F is automorphism, then F is homomorphism. Okay, if F is homomorphism, we'll have this property AB is equal to FA, FB. Okay, because if homomorphism definition is given by this FAB is equal to FA, FB. Now, what is this? Now, what is this? This is FAB. What is this? This is AB inverse. And what is this? A inverse, B inverse. Okay. So taking inverse both the sides, what we will get? For all AB belongs to G. For all AB belongs to G. Taking inverse both the sides, we get, what we get? You take inverse, you take AB inverse inverse. AB inverse inverse. Now we are taking A is B inverse inverse. For all AB belongs to G. Now this is AB inverse. We are taking 2 times inverse of AB. So what will be this? This will be again AB. Now AB inverse, B inverse, what will be this? The order change. It will be B inverse inverse, A inverse inverse. For all AB belongs to G. Okay. So what is this? This is equal to AB. What will be B inverse B? Inverse of B 2 times. This is B. Inverse of A 2 times. This is A. For all AB belongs to G. Okay. Now what is this? What is the meaning of this? Meaning of this is that G is abelian. So we have shown both the directions. A inverse, A goes to A inverse map that we call F is a automorphism if G is abelian, and then we consider G is abelian, and we have shown their direction that, okay, that F is automorphism. Okay. So we have shown that if F is automorphism, G is abelian, and if G is abelian, F is automorphism. Okay. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much.